Okay, so in this video, I want to introduce you guys to the concept of variables in C++. So, from the other languages you guys done, variables are obviously just labels that store certain values. And in C++, there are actually four fundamental types of primitive variables. Talking integers that hold just numbers, like common numbers are used to. Characters that hold just one character, so like a letter, a number, or a special character. Floats that hold decimal numbers, so like 6.8, and booleans that only hold two values, two possible values, true or false. So let's go into how to declare them in C++. So let's make a file, and remember the general skeleton of every C++ program, at least at this level. Pound include iostream into main brackets. All right. So, like I said, let's try to make an integer. Probably the most common variable used for teaching how to use variables. So, int. Notice how when we declared main here, we called it int main. Well, declaring a variable is the same way. Int x. So that same right there, we declared x to be an integer. However, we can't just print out x yet. And here's how you print out a variable. You just, as if you were just printing out any string, you just shove it here. And let's see how that goes. That's g++ wall main.cpp. It gives you an error right here saying, warning, x is used uninitialized in this function. So what it's telling, let's run, because it was just a warning, it wasn't an error. So let's run it and see what happens. So what happens is x, if you declare it like this, but don't give it a value. Notice we didn't give it a value at all. It says it puts a default value of 0. So that's not really useful if you want an x to have a certain value. So to give x a value, you put in another line x equals something like 5. And now, if you compile this, no error, and then it will just spit out 5. And if you're gonna just declare x and then give it a value, it's kind of redundant just to make it 2 lines. That's why you can just put it in one line like this: int x equals 5, and that is the standard way of declaring and initializing a variable. So this, in one line, declares x to be an integer and gives it a value of 5. Alright, the next thing I talked about was characters. So characters could be, you could put a, and notice the single quotes here, not double quotes like strings. Int a, character a, 4 is a valid character, even star is a valid character. So let's test that out. There you go. So characters can hold basically one character, right? That's char. Then there's float, which can hold decimal values, so positive or negative. So let's try negative 192.8.7. That's the float. So compile this, run it. There you go. And notice that if you try to make this an integer, the compiler will give you an error and it won't run. I guess in more recent versions of C++, it will, instead of giving you an error, notice how it truncated the variable. Instead of making it 192.7, it makes it just negative 192. Just know that if you have an integer, it'll, depending on what kind of compiler you have, it'll either give you an error, well, it will probably just give you a warning that you're trying to store essentially a float value into integer value. My compiler specifically doesn't seem to give me the error, it just goes with it. So you want to be really careful. Now the last one I said was boolean. Just bool. Bools can only have one value, true or false. And when you try to print it out, it won't print out true or false. It'll print out 1 or 0. False, 0 is associated with false, 1 is associated with true. So that's how you declare a variable. That's how you declare, initialize, and use variables. Before I continue, let's introduce one fundamental concept of most languages. Those are comments. It's helpful to comment any function you make, as long as the function is not completely obvious. So to make a one-line comment, you put 2 forward slashes, and then after that, notice the coloring. After that, everything becomes just a comment. The compiler doesn't even look at it. So let's comment it out as, let's comment showing how to use variables. And you can also put comments after statements, and everything after that will become a comment. So, makes, declares, and initializes. So, run this. It'll be the exact same because the compiler just ignores comments, as you should know. All right. So now let's move on to more fundamental properties of these variables. So let's look at the sizes thing I made earlier. So here I'm going to introduce a new function called sizeOf. So sizeOf is a function that you throw in either int, character, double, bool, basically any type that you want, and it will just tell you the size in bytes. So let's run this and see what happens. Oops. Where is it? Here it is. Ooh, wrong one. Yeah, and make sure you change the file name if you make a new file. Size is simply clear, and still 8 out though. Alright, so according to this, integers are 4 bytes, characters are 1 byte, 1 byte, not 1 bytes, floats are 4 bytes, and booleans are 1 byte. So, now, the range on integer, because it's only 4 bytes to find onto space, it isn't infinite. And depending on your architecture, it can be anywhere. It could be potentially like -2 billion to 2 billion, which is good for like most purposes. But sometimes you want numbers even bigger than that. Well, that's where long comes in. Longs, you can throw in really big numbers. And notice the size of long is 8 bytes, so you have double the amount of bytes. That's a lot of extra things you can work with. So if you want to get really big data, use longs. And doubles, so floats are only 4 bytes, so they're actually the same space. They take up the same space as integers, but they're allowed to have decimals. That's because floats aren't exactly precise. For probably the first few decimal places, they're precise, but after a bit, it's not really that close. So doubles, they're like floats, but they're much more precise. So actually, most older computers you want to only use float because you want to minimize the number of doubles, because doubles once again are twice as expensive memory-wise as floats. But now with most modern computers, you can just use double whenever you use float. So you'd use double. For most real applications, you want to use double because you want pretty good precision, and 8 bytes isn't really a big deal anymore. Alright, now last thing I'm talking about is different operations you can do on these variables. So let's take a variable int x equals 5, and take another variable. By the way, if you're gonna declare 2 variables in one line, you can, or 2 variables of the same type, so they're both integers here, you can actually declare them in the same line like this. Alright, let's declare one variable z, and let's declare that as x plus y. Now this does exactly what you would expect. Z would print out. Z was not. Oh, my bad. Make sure the last line, when you put a semicolon, everything after that is useless. So make sure you do not put a semicolon except at the end. And you have to separate these commas. That was just a typo. There you go. It printed out 8. So obviously it just adds the numbers together. Minus does the same thing. Oops. Subtract is the same thing. Here. Out. So 5 minus 3 is 2. Multiplication works too. That's the star operator. Division works too. Now here's the thing about integer division though. So 5 divided by, let's try 2. Oops. Try 2. So 5 divided by 2 is 2.5. But let's see what happens if you try to run this. 2, that's not correct. The reason for this is 2.5, that isn't an integer. Right here, this line says we're making out z an integer, but we're making z 2.5. So what happens is if you try to divide 2 integers, you have to get an integer as a result. That's just how operators work in C++. So instead of getting 2.5, it just ignores everything after the decimal place, so you get 2. So that's one thing to be worried about. And it can potentially be useful for certain applications, but if you're just trying to divide 2 numbers and get decimal, doing int z equals integer over integer doesn't work. Another operator that's pretty useful, is this one. Now this one is the percentage sign, that's the modular one. It lets you do modular arithmetic. So this basically does 5 mod 2, which is 1. Yeah, if you don't know what mod means, it's a common thing. Basically, it takes the remainder of the division. So 5 divided by 2 is 2.5, which is 2 with remainder 1. So it just prints the remainder out. So, those are all the basic the operations you can do with integers. With characters, you might think that if you make character x equals a, y equals b, what do you think would happen if I do z equals a plus b? What do you think would happen? And the first instinct, oops, x plus y, my mistake. It's y. Okay. Now obviously, it wouldn't print out AB, because AB is not a character. So what it does instead is that A has a certain integer value in the background, like a certain numerical value, and B has a certain numerical value as well. So it adds those numerical values together, and Z is the combination of those two. And you notice here, for me at least, it gave me this question mark. That means that my font does not have the character that it represents. So adding characters does not work as nicely as a non-experienced programmer would expect. Floats, you can add them. Floats and doubles, you can add them just as you would add integers. And booleans, you don't want to add bools. It just doesn't make sense to add true and false. Actually, I'm curious what's going to happen if I try to add booleans together. So let's add true. Let's add true plus true. So what does true plus true mean? Or let's add true plus false. More interesting. Y. True plus false apparently is true. Good to know. Generally, it isn't useful to add booleans together, but there might be some applications for it. Okay, so that covers how to make integers in C++, or how to make variables in C++. The fundamental primitive types are integers, floats, characters, and booleans, but of course it's always double if you want more precision than float, and longs if you want bigger numbers than integers. And in my next video, we'll try to show how to use these variables in useful ways.